Hello everyone, this is Varsha. I am currently pursuing my BE 5th sem in Sri Venkateswara College of Engineering. In this session, we will discuss about pumping lemma and its applications. Our agenda. In this session, we will discuss about what is pumping lemma for regular expressions and application, one example of pumping lemma for regular expressions, pumping lemma for context-free language and applications, and one of the example, advantages and disadvantages. Pumping lemma. Pumping lemma is a property of regular and context-free languages. It is used in theoretical computer science to prove whether the language is not regular or not context-free. Pumping lemma provides a way to show that a given language cannot be recognized by a finite automaton or a push-down automaton. It's a proof technique used to demonstrate the non-regularity or context-freeness of the languages. Let us see pumping lemma of regular expressions. The statement of this is for any regular language L, there exists a constant P. P is nothing but pumping length such that any string S in language with length at least P can be split into three parts, that is X, Y, Z should satisfy the following conditions. For each I greater than or equal to 0, x y power I z is in L, mod y is greater than 0, that is y is not empty, x mod xy less than or equals to p. Applications. To prove that the language is not a regular, we should use the method of contradiction. That is, firstly, we have to assume that the language is regular and then show that for some string the condition of pumping lemma is violated. This contradiction implies that language is not regular. Let us see with an example. Uh, Proving a language 0 power n, 1 power n, where n greater than or equal to 0 is not regular. Let's use the pumping lemma to prove the language is not regular. As we said before, by method of contradiction, that is, by assuming L is regular, assume for the sake of contradiction that L is regular. Then, according to pumping lemma, we have to we have to split the length into at least three characters, that is X, Y, Z. We have to choose a string in L. Consider the string 0 power P, 1 power P. This is in L. So, this is our string. Now, applying the pumping lemma, according to pumping lemma, we should write the string as equals to x, y, z. That the condition holds that for I greater than or equal to x, y power I, z should be in L. Mod y should be greater than 0. Mod x, y should be less than or equals to p. Now, let us take our string. Let us consider the possible decompositions. Since xy is less than or equals to p, the substring y must contain only of zeros. When we pump, that is, when we set I is equals to 2, we set a string xy power 2z with more zeros than ones. This new string is not in L, contradicting the assumption that L is regular. Conclusion. So, the contradiction implies that the language L is regular is false. Therefore, our language is not a regular language. Hence, we can conclude that the given language is not regular. Now, let us go with pumping lemma for context-free language. Statement. For any context-free language L, there exists a constant P, that is the pumping length, such that any string S in L with length at least P can be split into 5 parts, that is U, V, W, X, Y, should satisfy the following conditions. For each I greater than or equals to 0, U, V power I, W, X power I, Y should be in language L, and mod V, W, X should be less than or equals to P, and mod Vx should be greater than 0. Now, let us go with the applications. So, similar to the pumping lemma for regular languages, the pumping lemma for context-free languages should also use the contradiction process only. It involves assuming that L is context free and then selecting a string S from L that satisfies the condition of pumping lemma. By analyzing the possible decompositions, we should find a contradiction and showing that L is not context free. Now, by taking same example that is not context free, we have to use the pumping lemma. We have to assume that L is context free, and for sake of contradiction, then we have to assume a string in L of pumping length P, and we have to split that into UVX, UVWXY with a specific condition. Now we have to choose a string. Let us assume our string is 0 power P, 1 power P, because it has equal number of zeros and ones. Now, applying the pumping lemma for context-free language. That is, according to the pumping lemma, we can write S is equals to U, V, W, X, Y, such that the conditions should hold the following conditions. That is, U, V power I, W, X power I, Y is in L, and mod V, W, X should be less than or equals to P, and mod Vx should be greater than 0. Now, we shall analyze the decomposition. That is, let us consider the possible decompositions. Since the mod VWXY is less than or equals to P, the substring VWX must consist of zeros or only of ones. When we pump VWX, that is, set I is equals to P, the number of zeros and ones will no longer be equals of same length. This is leading that the string is not in L, contradicting the assumption that is L is context free. So, by method of contradiction, as it is not obeying the following conditions, we can say that it is not context free language. So, we can say that our language L is not a context free language. Now, let us go with the advantages of pumping lemma theorem. That is, it is useful for proving the non-regularity. That is, primary advantage of this pumping lemma is it is utility in proving that a language is not regular. If it satisfies the pumping lemma, then it can be concluded it is not regular. Then it is widely applicable. The pumping lemma is applicable to a broad range of languages and it is not limited to specific types. This makes the pumping lemma as a versatile tool for proving the non-regularity of various languages. And the next advantage is its simplicity. The pumping lemma theory is very simple. Thank you.